Hello and welcome everyone. In today's video, we will learn about reflection agents in LangGraph. Let's first understand what reflection is. Reflection is a prompting strategy used to improve the quality and success rate of agents and similar AI systems. It involves prompting an LLM to reflect on and critique its past actions, sometimes incorporating additional external information such as tools and observations. So basically, to achieve reflection in LLM-based systems, we have multiple LLM agents. Some that generate content. Others reflect on generated content and give constructive criticism that can then be used to optimize the next generation in the cycle to make the content better. Let's look at the types of these reflection types we can work with. There are mainly three types of reflection agents: basic reflection agents, and language agent tree search, LATS. In this video, I am going to focus on basic reflection agents. Let's get started. Now, let's create the virtual environment by following this command. Our virtual environment has been created. Now we will activate our virtual environment using this. Name of the virtual environment, /scripts/activate command. After activating the virtual environment, we will create the requirements txt file to write down the required libraries. Now run this command to install all the required libraries. All the required libraries have been installed. For LLM, we will use Grok. Now, we will set up our environment variables. These variables include our API keys for Grok, which we will store securely using a.env file. This ensures our sensitive information stays safe. Create the .env file. Put your Grok_API_ key here. To get the Grok API key, open your browser and type grok.com. Now click on Grok Cloud and click on the API keys section. Now click on the Create API Key to generate the Grok API key. Next, the name to your API key and click on Submit. Now copy the API key and paste it into the .env file. Create a new file to write the code. First, let's understand about basic reflection agents. A basic reflection agent is a type of agent that is capable of introspection and self-improvement. This agent leverages reflection to analyze its behavior, understand its strengths and weaknesses, and adjust its strategies accordingly. In today's video, we will create two main LLM agents. One will act as the generator, and the other will act as the reflector that criticizes the responses from the generator and suggests constructive feedback. Let's start with the necessary imports and setup. Import Essentio. From LangGraph, graph import END, message graph. From typing import list, sequence. From LangChain_cord, messages import base message, human message. Import OS, .env. From LangChain_grok, import chat grok. From LangChain_cord, messages import AI message. From LangChain_cord, prompts import chat prompt template, messages placeholder. Essentio manages asynchronous tasks. END, message graph, constructs and controls our message processing flow. List, sequence, provides type annotations. Base message, human message, and AI message define message types from LangChain for structuring our conversations. OS, .env, manages environment variables. ChatGrok is an interface for the Grok model. Chat prompt template, messages placeholder, create chat prompts dynamically. Next, we will load our environment variables to keep sensitive information secure. .env load_.env. Let's move ahead and implement the two main agents in the basic reflection architecture. The generator agent will do the generative part of an LLM, generating answers to user queries. Then the generated response, initial response, will be passed on to the reflect agent to reflect on it and give us constructive feedback. The constructive feedback will then be passed on to the generated agent to fine-tune its initial response. We'll do this in a loop for n number of times. So, let's move ahead and create these two agents. Now, we will define a prompt template for generating responses. Prompt equals chat prompt template. From _messages. System. You're an AI assistant researcher tasked with researching on a variety of topics in a short summary of 5 paragraphs. Generate the best research possible as per user request. If the user provides critique, respond with a revised version of your previous attempts. Messages placeholder, variable _name equals messages. System, defines the role and behavior of the AI. Messages placeholder inserts dynamic user and AI messages. Next, we will set up our language model. LLM equals chatgrok. Temperature equals 1. Grok underscore API underscore key equals OS. Geetenv. Grok underscore API underscore key. Model underscore name equals llama 3-8b 8192. Temperature controls response variability. Grok underscore API underscore key authenticates our API requests. Model underscore name specifies the model we're using. Next, we combine the prompt and model into a generation pipeline. Generate equals prompt LLM. We also need a reflection prompt for feedback. Let's create it. Reflection underscore prompt equals chat prompt template from underscore messages. System. You're a senior researcher. Provide detailed recommendations, including requests for length, depth, style, etc., to an assistant researcher to help improve this research. Messages placeholder, variable underscore name equals messages. Now, we will set up the reflection pipeline. Reflect equals reflection underscore prompt LLM. Next, we will define two asynchronous functions, one for generating content and one for reflecting on it. Async def generation underscore node, state, sequence, base message. Return await generate, invoke, messages state. Generation underscore node function calls the generate pipeline with the current state of messages. Async def reflection underscore node, messages, sequence, base message, dash list, base message. CLS underscore map equals AI, human message, human, AI message. Translated equals messages 0 plus. CLS underscore map, message type, content equals message content. For message in messages, 1, smiley face. Res equals await reflect, invoke, messages translated. Return human message, content equals res.content. Reflection underscore node function translates message types, invokes the reflect pipeline, and prepares feedback. Now, we will create and configure our message graph. Builder equals message graph. Builder, add underscore node. Generate generation underscore node. Builder, add underscore node. Reflect, reflection underscore node. Builder, set underscore entry underscore point. Generate. Message graph structures the workflow. Add underscore node adds generation and reflection nodes. Set underscore entry underscore point sets the starting point to the generate node. Next, we will define the condition for continuing the process. Def should underscore continue, state, list, base message. If len, state, for. Return end. Return, reflect. Should underscore continue function stops after 5 iterations to avoid infinite loops. Now, we will define the edges and create the graph. Builder, add underscore conditional underscore edges. Generate, should underscore continue. Builder, add underscore edge, reflect, generate. Graph equals builder.compile. Add underscore conditional underscore edges. Links nodes conditionally. Compile, prepares the graph for execution. Finally, we will define the function to stream responses and run the asynchronous loop. Async def stream underscore responses. Async for event in graph.stream. Human message. Content equals where is Eiffel Tower? Sad face. Print, event. Print. Stream underscore responses starts with an initial user message and prints the events. Next, execute the workflow. Asyncio.run, stream underscore responses. That's all we needed to do to implement a basic reflection agent. Now run the file. Here you can see our output will iterate to the 5 steps. And you can see the response is started from the generate node and provide the information about the question. And here our reflect node or agent will do a research on this generated content and provide the feedback. And after providing the feedback, it goes back to the generate agent and regenerate the content based on the feedback. And after regenerating the content, generate agent passed it to the reflect agent. And it provide the feedback and passed it to the generate agent. Finally, generate agent provide the final output. Now that you've applied reflection to an LLM agent. So in today's video, we learned about reflection agents in LangGraph and implemented the basic reflection agents. I hope you found this video helpful. Thanks for watching, and let's meet again in the next video.